Hello everyone, this is Dr. Giuliano. In this video, we're going to be talking about how to calculate the absolute risk reduction, abbreviated ARR, the number needed to treat, abbreviated NNT. Now, to find the information to do these calculations, you want to look at the results section of a journal article, and it may be in the text or in a table. But let's go ahead and make a table and do the calculation ourselves. So we'll want to make a 2 by 2 table, and the rows in the 2 by 2 table will signify whether the patient has an outcome or not. A positive sign that indicates outcome and negative no outcome. And then our columns will be our intervention and our control group, or INC respectively. Now let's go ahead and label our cells. So in the intervention group, we're going to have cell A and cell B. And cell A is those that get the outcome, and cells B is those that don't get the outcome. The same goes for our control group. We'll have cells C and D, which mean the same thing as the intervention group. Now let's calculate the absolute risk reduction. So the absolute risk reduction is equal to A over A plus B in the intervention group. And what this equation means, it's the rate of the outcome in the intervention group. And then we subtract the rate of the outcome in the control group. And this simply gives us our absolute risk reduction. We'll talk more in the example specifically about what this number means, as it will make more sense. The null hypothesis for the absolute risk reduction is that it is equal to 0, meaning that there is no difference in the rate of the outcome in the intervention, the control group. So once you get the absolute risk reduction, it's very easy to get the number needed to treat. And all you have to do is take 1 divided by the absolute risk reduction. And that will get us our number needed to treat. Now, let's go ahead and apply what we learned to an example. Again, we're going to draw a 2 by 2 table. And this time we'll look at the outcome being whether someone experienced death or they're alive at the end of the study. And the intervention we'll look at is Dr. Giuliano's multivitamin. And the control will be a placebo. And let's say 19 people die in the study. By the end of the study, 19 people die and 206 are alive. In the placebo group, 33 people die and 192 are alive at the end of the study. So we can use this to calculate our absolute risk reduction, just like we showed before. So we have our A over A plus B, as shown in the previous table, and then we subtract the outcome rate in the control group, or C over C plus D. And if you look at the denominators, 19 plus 206 and 33 plus 192, they're both equal to 225. So I'm just going to take 19 minus 33 and then divide it by 225. Pull up my calculator. 19 minus 33 divided by 225, and we get this value here. So let's go ahead and write that down. The negative 0.062 is our proportion, or 6.2% reduction. So what does this mean? It means that Dr. Giuliano's multivitamin reduced the absolute risk of death by 6.2%. Now this is somewhat different than relative risk reduction, because relative risk reduction is typically higher because absolute risk depends on how frequent something occurs in society. And the more rare it is, the higher your number needed to treat values are going to be. Now let's go ahead and calculate our number needed to treat. So we take 1 over 0.062 and we get a value of 16.13, and we have to round up because we can't have a fraction of a person, so we round up to 17. And so what does that mean? This means for every 17 patients treated with Dr. Giuliano's multivitamin, you prevent one death. So you have to treat 17 to prevent one death. Now let's look at an example of number needed to harm. So for number needed to harm, it's the same calculation, but let's say we got the data in a little bit different of a way. And this time we'll look at an example of Dr. Giuliano's multivitamin and side effects. Let's say it causes diarrhea. So let's say Dr. Giuliano's multivitamin causes diarrhea in 20% of patients, and in the placebo group, diarrhea occurs in, let's say, 10% of patients. And so what we can do is we can use this information. We can take 20% minus 10%, and that gives us a 10% absolute risk reduction. And that's actually a 10% increase in the side effect. So we're going to be talking about number needed to harm. Now realize that 10% is a 0.1 in as a proportion. So we'll take the reciprocal of that, and that is equal to 1 divided by 0.1 is equal to 10, and that's our number needed to harm. Now you can use the number needed to harm along with the number needed to treat. So we had a 17 number needed to treat to prevent one death, and you can make a decision for your patient based off this information. Now, most drugs are certainly more complex because they have many more side effects, and maybe the number needed to treat is higher than 17. So you need to take all these into account, and you can use this information to communicate with other healthcare providers to get your point across in a succinct manner.